Here's another example. The table below gives data on the number of breeding pairs of merlins in an isolated area in each of the 9 years and the percent of males who returned the next year. So in a particular year, the number of breeding pairs and the percent of the male birds that return the following year, there seems to be some sort of relationship. The data show the percent returning is lower after a successful breeding season, and that the relationship is roughly linear. So here is a confirmation that the relationship is linear. So what are the two variables? Number of breeding pairs and the other variable is percent males that return, percent of the males that return the following year. So these two are the variables. Now this is the fitted equation that's given to us based on some sort of a statistical software. R squared is given. So that is R squared, that's equal to 0.6309. Now when we look at this equation, it says percent returning equals 157.6822 minus 2.9935 times the number of breeding pairs. So this looks like Y equals B plus MX. The number that's multiplied to the explanatory variable. So the response variable is the variable on the left. So that is percent returning male birds. And the explanatory variable is number of breeding pairs. If the number of breeding pairs, let's see what it says. The percent returning is lower after successful breeding season, which means as the number of breeding pairs goes up, the percent returning males is lower, which means it goes down. So the relationship is a negative relationship, which means as one variable increases, the other decreases. And if you look at the slope of the regression line, how do we identify the slope? There are two numbers here. The lone number is the B, which is the intercept, 157.6822. The number multiplied to X is the slope. Slope is the number multiplied to X. Slope is a constant. So the slope is negative 2.9935. Now, in general, we know that as the number of breeding pairs goes up, the percent of males returning goes down. It's a negative relationship. And clearly that's a negative slope, so that's a negative relationship. But if we had to precisely explain the relationship between number of breeding pairs and the percent returning using the definition of slope, then this is the slope 2.9935, which is approximately 3, is equal to rise, which is the change in the vertical direction, that is change in Y over change in X, which is the run. So that's rise over run. So 3 divided by 1, so that's negative 3, sorry, not positive 3. So that's negative 3 over positive 1 is the change in Y, which is the percent of males returning the following year divided by the change in X, which is the number of breeding pairs. Let's just call it N. So now we can describe the relationship using this equation. So the change in Y is positive. The change in, X, the change in the number of breeding pairs is positive, and the change in the percent of the birds returning is negative. So this is how we're going to explain the relationship. We'll start with the denominator, which is the change in X. So X is the number of breeding pairs. As the number of breeding pairs increases by 1, why am I calling it an increase? Because it's positive, by 1. The percent of the birds returning decreases by 3. Why do we call it a decrease? Because the number is negative. So make a sentence. It says, as N, which is the number of breeding pairs, increases by 1, the percent of the birds returning, write it as a whole sentence, decreases by 3. Okay. So now, what is the equation of the least square regression line? You look at the fitted equation. So write down this equation. This is the entire equation. So percent birds returning is equal to 157.6822. If you can see, that's the intercept, minus 2.9935 times the number of breeding pairs. So that is the equation. Now it says use the equation to predict the percent of returning males. So what is P when there are 30 breeding pairs? So we plug in 30 into this equation. So the number of breeding pairs, N, is 30. Now figure out what this is. And when I use my calculator, I get the percent as 67.88. So what this means is if the number of breeding pairs is 30, then the percent of returning birds is 67.88. What percent of the year-to-year variation in the percent of returning males, which is your Y, what percent of the variation in Y can be explained by the straight line relationship with the number of breeding pairs the previous year? This is a clear-cut definition. It is given by R squared. The percent of the variation in the Y based on the change in the number of breeding pairs, which is X, is given by a percent that comes out of R squared. So R squared, change it to a percent, it's 63.09%. So roughly 63% of the year-to-year variation in the percent of returning males can be explained by the number of breeding pairs. Find the numerical summary that describes the strength of the linear relationship between the two variables. What exactly is this question asking us to find? By definition, R, the correlation coefficient, is the it gives us the strength of the linear relationship. Now R squared is equal to 0.6, let's see what it is, 6309. That is R squared. Now how do we find R? By taking the square root of 63.6309. And let me use my calculator here. The square root of 0.6309 is equal to 0.7943, approximating it to the fourth decimal place. Now what this tells us, there's one more thing we need to fix before we give the final answer. Remember, this can be plus or minus when we take square roots, but here we know that the relationship is negative. So be careful. Since the relationship is negative, the correlation coefficient is also negative. It's 0.7943. So how did we get it? By taking the square root of the r squared. And remember that r squared is always positive because we're squaring a number. But when we are taking the square root, the answer could be either positive or negative. But in this case, we know for sure it is negative, and hence we have r equals negative 0.7943. So make sure you know how to use the definition of slope to describe the relationship between the two variables. So this is extremely important. Then you have to know what the regression equation is and how to use it. You plug in an x to figure out a y, to estimate a y. So the y here is percent. Next thing is, do we know the definition of r squared? It's the percent of the year-to-year variation that can be variation in y, which is the response variable, that can be explained by the x, which is the number of breeding pairs in this case. How do you find the numerical summary given r squared? Note that r squared is always positive, but when we take the square root of r squared, it can be positive or negative. But read the question carefully to determine whether the relationship is a positive relationship or a negative relationship, and based on that, decide whether the correlation is positive or negative. Note that this is strong, if not moderately strong. Either one, you could call it a strong, negative, linear. Since we already know that it's linear, we can call it a strong, negative, linear relationship.